Hey, Mr. J here with a quick little lesson. Um, Really nice job for almost everybody on that last quiz. Uh, so we're able to move on. We can jump ahead to Module 7. If you remember, the last module we were in was Module 4. So I'll talk a little bit about what we missed by going to Module 7. But it's time to step on the gas a little bit, maybe not just in the next 2 days, but when we get back from break and try to get ahead in the geometry curriculum. As you might have guessed, we did a lot of algebra recently, trying to remediate some of the skills that I noticed weren't perfectly there, so that you're ready for high school algebra 2. But now we have to get back to geometry. And a big part of geometry is what you see over my right shoulder here, this idea of triangle congruence and how we use this theme of triangle congruence to really work on proofs. So we're going to get back to proofs in this unit, which will be mostly in December. And as we wrap up this quarter on December 16th is the last day of the quarter. So please make sure you're on top of problems of the week and homework makeups and corrections and possibly retakes. So be on top of all that. Make sure you're in touch. There'll be some free time this week that I have, so you can be in touch by email if you have time. Module 7 is within Unit 4. As you know, this textbook is a bit confusing in its numbering. They have units, and then within it, the module numbers keep counting. So our last module was Module 4 in Unit 3. Now we're in Module 7 in Unit 4. Doesn't really matter about the numbering. But you'll see that we just have two modules within this unit, congruent triangles and polygons, and triangle congruence criteria, what I call shortcuts. Okay, so we have a little lesson here. I do want to do a bit of review of what we missed, and so we'll talk about that. Before we get to that, let's talk for a second about the learning mindset versus fixed mindset and the growth I've seen in you guys in terms of handling frustration. That's what I kind of consider this. The learning mindset, receiving constructive criticism, getting frustrated, not being successful the first time, and how you handle that and how you move through that. Okay. Um, so this is out of your book. It is something worthy of your time to take a look at. I want to go over to this next, which is a lot about what we missed and not really worthy of our time. I think a lot of it is pretty intuitive and pretty basic. And it's about translating figures. And if you remember, we were doing parabolas and vertex form, that quiz I mentioned that you did well on, and how we transform things by just shifting them. And we can shift other things, transform them, or something known as isometries, by just saying all the x values go down by 4 and all the y values go up by 1. And if we had this quadrilateral, you'll see that it moves around and shifts, but it does not change in terms of its area, in terms of its side lengths, and in terms of its angles. So these are one type of translations, and I didn't think we needed to go through and draw these on graph paper. So we can also rotate things. If you have a triangle here at these coordinates and we say move it counterclockwise or by 90 degrees or counterclockwise, I wanted to show you an example of this. So I have one over here. So say we have this triangle, and I did this as you can see in GeoGebra. Do you think if I change its rotation about a point, so I'm going to rotate it about this point D, and I did that just in here. There's a great feature in here about rotate around a point, and then I added a slider. So if I'm going to rotate it 90 degrees about the point D, right here, can you see what happened? It rotated left, so that's counterclockwise around point D, and now we have this shape. Do you think this shape is congruent or the same with the original? I do like they use these little prime symbols here. You see C prime correlates to C, and A prime correlates to A prime, and B correlates to B prime. Or we can rotate 180 degrees. And again, these two figures are still congruent to each other. They've transformed and just rotated, but still the same. And we can keep going to 270 and back. 360 would be back to the original. And you can actually move this point. Oh, I guess I fixed that there. But you might move that point somewhere else. And then we could talk about the rotation there. But that's not a skill that I consider that important. And so I just wanted you to know about the transformations here. And that transformed, rigid transformations do not change the figure, and that they are congruent. There's some other topic, another topic we'll do called dilations, where we'll dilate an object from a point, and that will enlarge or reduce, but that's coming up later. Let's go back to notebook for a second here and keep moving along. All right, our first module, congruent triangles and polygons. And we're going to understand congruent figures. I can determine when figures are congruent. So let's take a look here. A nice biconditional statement for us. Two figures are congruent if and only if one can be obtained from the other by a sequence of rigid motions. That just means that horizontal translation and a vertical translation. So good enough there. Let's talk about what we can do if two figures are congruent. If two figures are deemed to be congruent, so this is an important thing here. This is called a congruent statement right here. And I want to highlight that for a second, because I want you to get good at making congruent statements. So this is saying that triangle LMN is congruent to triangle PQR. And if we know that, if that's given to us or we prove that to be true, then all of its components are congruent. So consequently, and we write this in a specific order, this is vertex L will correspond to vertex P, and if they are congruent to each other, then those angle L and angle P must be congruent. Angle M corresponds to angle Q. That means those angles would be congruent. And angle N corresponds to angle R, that's the last letter in the congruent statement, so those would be congruent. We can also say that if we have side LM, the first two letters would then correspond to side PQ, because those are the first two letters. Side MN would correspond to side QR. All right, so we can interpret different things by looking at a congruent statement. And that's what it says here. LM corresponds to PQ, and angle L corresponds to, and is congruent to, angle P. Okay? So two figures are congruent if and only if corresponding pairs of sides and corresponding pairs of angles are congruent. So there's an example here to look at. And this is out of your book, and you might want to take a little extra time to go back and take a look at it. So if all the pairs of corresponding sides and all the angles of two figures are congruent, then the figures are congruent. You know, triangles don't have that many features. They have side lengths and they have angles. And if we go through and we prove that every angle, so the 37 and the 37 is congruent, and a right angle and a right angle are congruent, and the 53 and the 53 are congruent, and the 3 goes with the 3, and the 4 goes with the 4, and the 5 goes with the 5, then we have been what I call exhaustive. We have checked everything, therefore these two triangles are congruent. Okay, that seems like a lot of work to check all 6 parts, but for right now, that's what we're doing. We're checking all 6 parts, and if they're all the same, then we can say the two figures are the same. Okay? There's another concept here, a pretty important concept, a pretty intuitive concept. It's called the third angles theorem. You'll see that this is a theorem, so it can be proven. And I bet you can take a quick guess at how we might prove this, but let's read and see what it is first. If two angles of one triangle are congruent to two angles of another, okay, A is congruent to D, and C is congruent to F, then what this theorem says is then we can assume that B is congruent to E. Now, do you know why that would be true? If you paused and thought about it for a sec, why would that be true? Would it be easier if I added numbers? Say this is 110, right? And this is 110. And say this is maybe 40. And this one's 40. Can we conclude, therefore, that's supposed to be a 4, that B and E are congruent? Why would they be congruent? Without, what mathematical principle or what idea do you have about triangles that allows us to say B is congruent to E? Would you know that the interior angles of a triangle add up to 180? And if we have 2 of those 3 in 2 triangles, does it make sense that the third must also be the same, in this case 30, right? Because 110 plus 40 is 150 plus 30 makes that 180 total. So this one has to be 30 as well. So there would be a proof we could do to prove the third angles theorem. Okay. So if they gave us enough information that said, you know, this is congruent to 12, and 9 is congruent to 9, and 15 is congruent to 15, and 90 is congruent to 90, and this angle is congruent to this angle, we can then, by third angles theorem, say this is congruent to this, and therefore we can do the math of setting these two equal to each other. Okay? And so, and here's another congruent statement. Very good. We can do this with other figures. If we're told that this hexagon is congruent to this hexagon, these represent scales on a shark. Kind of cool looking. Aren't they really geometric when we zoom in on how a shark has scales like this? It reminds me of biomimicry that they do in the 9th grade down in the iLab, and how we use nature maybe to design products because they're very efficient. All right. So if we know these two figures are congruent, then we can say corresponding parts are congruent. I wanted to keep our lesson kind of short here today. We'll come over here. This is the end of the section from your textbook, and a little bit more that we know the triangles are congruent because we have enough information to prove all the parts. Maybe the third angles theorem is helping us prove those last angles are congruent, and I think you can do that. The last thing I'd get to is to go down here and talk about that triangle congruence statement. When triangles are congruent, one triangle can be moved through one or more rigid motions. That's just that shifting or translating. And then to coincide with another triangle, all corresponding sides and angles will be congruent. And this here is that triangle congruence statement. And those are the corresponding sides. You see AB goes with DE, BC goes with EF, and CA, or AC, CA goes with FD. The good news, and I agree this is good news, what we're going to get to soon is maybe some shortcuts that we don't need to prove all 6 facts, and that's going to be coming up pretty soon. All right, that's the end of our lesson. We'll have one last homework assignment due before the break, and other than that, I hope you have a great holiday and that you travel safely if you're traveling far, and that we will see you next week. Okay, thank you.